I want to talk today about drawing some Lewis structures, and the compound that we're going to be looking at today is this one. You'll notice it has a negative charge on it, and we're going to have to account for that negative charge when we count up our electrons. The steps that we're going to follow are the same ones that we always follow. We're going to count the number of valence electrons. We're going to give all atoms an octet, and then we're going to adjust for the number of electrons that we do or don't have. So if we count the number of electrons we have available, what we're going to find is that we've got one nitrogen with 5 valence electrons. We've got 3 oxygens, each has 6 valence electrons. And then we've got a -1 charge, which means we've got 1 extra electron. So I put 1 negative times 1 electron for each negative gives us 1 more electron. That adds up to a total of 24 electrons. The next thing we're going to do is we're going to give all atoms an octet. When we do that, our Lewis structure will initially look like this. Well, when we count the number of electrons that are there, what we find is there are 26 electrons there. We only have 24 valence electrons, so we have to do something to get rid of some of those valence electrons. And what we're going to do is we're going to remove 2 lone or non-bonded pairs and add 1 multiple bond for every 2 extra electrons that we need to get rid of. The question on this molecule is, which electrons do we remove? Because we've got a couple of options. We can remove the electrons from this nitrogen, and then, for instance, we can remove the electrons from that oxygen and put a double bond between that nitrogen and the oxygen. Get lined up like that. That gives us 24 valence electrons now, which is what we want. But there are other options. For instance, I can put those electrons back up on that oxygen, and I could remove these electrons from this oxygen and use them to make the double bond between the oxygen on the left and the nitrogen. Or I could return those electrons and remove a non-bonded pair from the other oxygen on the right and use that pair of electrons to make a double bond between the nitrogen and the third oxygen. And the question is, which of these is correct? And the answer is that they're all correct. They're what are called resonance structures of this molecule, which is nitrate. Nitrate has 3 different resonance structures that we can draw. Whenever we have multiple resonance structures that are all correct, they're called resonant. Whenever we have multiple Lewis structures that are all correct, they're called resonance structures. In this case, we can draw 3 of them. And quite often we represent those multiple resonance structures like this, with the double bond between the oxygen on the left and the nitrogen here, between the oxygen and the right on the right and the nitrogen here, and in the third structure between the nitrogen and the oxygen on top. They all have the correct number of atoms connected in the same way with the correct number of valence electrons, so they're all correct resonance structures for nitrate. These double-headed arrows, an arrowhead on both ends of the line, are specific arrows used in chemistry for representing resonance structures.